last but not the least, we have Professor Keshari, professor from IIT. IIT Delhi, I would like him to kindly tell all of us what is the next gen technology particularly. Maybe you can touch upon that. Sure. The next gen technology which could be really useful for water, because you must have seen all are talking now the same.
Yeah, thank you very much, distinguished dignitaries on the dais and the learned delegates. So I have a presentation, but I'm not going to discuss all the slides here, but certainly as it has been said by the chair and then the organizers, I have to wrap up within 7 minutes. We are now in the digital era, and the new technology or the emerging technology which we have right now, that is the AI. AI is something where in every area it is being applied. You can make use of that, like if you say in AI, certainly like machine learning or neural network, and the IoT, which is basically a data measurement. It gives you the data, and you can increase the data. You can have the better quality, so it helps you in monitoring. The another what we are seeing, the geospatial technology. In geospatial, if you see at here 3 parts. One is giving you the GIS, which is basically a mapping tool, which helps you to analyze, retrieve, and process all kinds of data and generate the maps for your decision making or for the better governance, basically. If you look at the remote sensing, which is again gives you the data and also the analysis, because you are getting those data from the satellite. Nowadays, even the drones have come in, and you can make use of high resolution data, multispectral data, and through the drone, even for those areas which are inaccessible, and of course the GPS, the system which helps you in the navigating, and that is what helps you to generate or to make it geo AI, like the geo. I mean here you can refer to the actual lat long and the coordinates, and then you can do the analysis. So now we are entering into the geo AI era. And certainly these technologies are going to help you in better governance, also in managing and addressing some of the problem, especially which are of critical nature. Like all mapping tool can be utilized for the identifying the hot spots where you are going to predict something, where you need the lead time for any kind of the analysis. So there certainly this is going to help you. But what also we need in terms of the policy, because many of the technology, whatever have been presented by the speakers, you might have seen they are mostly in some are in service sector, which are in operation, something which you can make use of also in the planning, during the planning stage, and taking the measures at the later stage and managing. So you have to make use of this technology even in the planning, operation, and the management, not only restrict only up to the maintenance or the servicing. But still, like suppose if you take the case of the drainage, the pipelines, the sewage pipelines, or water supply pipelines, you see, whenever we construct as a civil engineer any building or any infrastructure, we always say, even all CPWD, PWD, all departments of the India, everywhere in every state, they will say, what is the structural stability, whether we have got the structural proof checking or not. But you'll be surprised to know, nobody asks, where is your pipeline? Where is on the map? You have the whole map layout, but where is pipeline? Water supply pipeline? Where is your sewage pipeline? Where is drainage pipeline? No. Like in Delhi, every year you see the drainage condition, but do we have where the pipes are going on for the sewerage or for the storm drainage or for the water supply? No. So we have to go on digging whenever something comes and some repairing comes. So this is where we need to shift in the policy, that when they get the clearance, when they get certification, we can go good for the construction. They should also say that where is those line on your GIS map? Please bring those drawings, and then only we'll approve it. So that kind of thing should be there. Like I'll tell you, we had done some project for defense, on the border areas for identifying the route alignments for military operations or for some other purpose, security purpose. Also at the border, what should be the fencing where the people come across the rivers or the streams, and then during the those alignment of the roads, where we need to construct the bridges or some causeway. So identifying those areas or those spots. Certainly, if you go by conventional surveying or GPS survey, it is going to take huge time and it may not be possible also because it is not accessible. But we could make use of the satellite data and we could do that. So they implemented in the tender document itself that we have to get it analyzed through the remote sensing, and then only we will be accepting the final layout of those designs. So that is where I see that you need to bring into the implementation stage that you make use of this technology while you are taking a decision, while you are working. So that is what I am trying to say you. I'll just show you a couple of slides, not more probably. What we have done at IIT, many things, but I'll show you the few slides. What is that?
The green one.
Green one?
Right.
Okay.
Point hit.
This one?
Yeah. No, the green.
Oh, okay. Right,
The green triangle, no.
No, green
This
triangle.
is-
Okay, it's fine. Okay, got it. Thank you. So I'll just show you here the one of the thing what we have done by making use of the geospatial technology. We have tried one to see how much precise you can get the land-use-land cover. The land-use-land cover is one of the important thing, for the data, for all kind of the modeling, for all exercise, especially in the urban areas. In the urban areas, you may not be having so much information even using the spatial technology, the remote sensing data, because resolution will come only up to the pixel level. So we have developed by making use of the machine learning a sub-pixel image classifier. By making use of the spectral unmixing algorithm, there we made the use of different algorithms. You can see here, we developed these algorithms and we could find that this PN MESMA, which is basically pre-screened and normalized multiple end member spectral mixer classifier, will be able to process all images at the resolution of sub-pixel level. So lesser than a pixel, whatever the resolution we have for a satellite. And this can give you a best estimate for the land use land cover in the urban setup, and you can make use of for your specific applications. So this is one thing I thought I should share with you. The another what I would like to say, that let us say if you are making use of modeling, the modeling exercise, and then also we club with some kind of the decision science. The decision science, that means here I am talking about the optimization techniques which helps you in giving the best decision. So like here in the previous case, sorry, no.
No, the upper one.
Okay. Fine, sorry. Oh, this one, fine. So here if you see, yeah, this I wanted to show you. This is the watershed. Oh, it is going ahead. I'm confused with the slides, whether going back or front. It is always going back, the front. Where is that?
This is for front.
Oh, this is our back. Okay, sorry. Yes. So here you see what we had made here, that there is a river. You see here, this was we did for the South Africa. So there is a river. They they make use of this river water for water supply to the Addis Ababa in Ethiopia, and they also make use of a lot of tube wells to pump it out along the river, and that is where they are able to then supply the city. But some of the tube wells get dried. The river also shows sometimes of the bad condition at the downstream because of the no environmental the flows in the river. So we try to develop a framework here which helps in the regulating the pumping from the tube wells, and also the regulating the discharges from the river, so that you are able to maintain the ecosystem services at the downstream of the river. You are also allowing the sustainability of the tube wells, so that you are going to get more water for a longer time, and then you are not disturbing the hydrological system of that area. So if you look at here, by combining this modeling and this geospatial technology, we could arrive at this, the diagrams you can see. On a monthly basis, it may show you that we are not pumping over than whatever is required optimally. But if you look at the tube wells, individual tube wells, you can identify on the right hand side that there are some of the tube wells where we are pumping much more water than what optimally it is required. So certainly after certain years, those tube wells will get dried, and also there will be depletion of the river water in the river water at the downstream. So that is where you can make use of this technology. The another I wanted to show here that we had done this work for the Bhatti mines area, where we wanted to see that whether these areas could be currently being used for the recharging purpose, which helps in the recharge of the groundwater. But the municipal corporation wanted some time back in the past that whether these can be utilized, these depressions for the landfill sites or not, because in Delhi we have all land sites filled. But we had did the complete analysis of here, and then we also went for the environmental impact analysis. We had said for no, and currently we don't have those kind of the system right now. So, but you can see we try to model how the flow is taking place, how the contaminant is going to travel and transport from those areas. So that is where it basically helps you. The another slide just I wanted to show you to assess whether you have a groundwater, the area which is vulnerable to pollution. You can identify those spots, and then what kind of the measures you should take. So that is where this diagram has been presented here. Here we have made use of the remote sensing data and the conventional data. Both data we have combined, and we did the analysis in the GIS framework. We could develop different kind of the thematic layers. We could integrate, and then we developed some kind of the index-based, entropy-based indexes, so that it helps you in identifying the hot spots to take the measures, the interventions for the managing the groundwater. The next, I'm going to conclude with this. So here we try to also assess how is the flood vulnerability, where is the hot spot which are going to be get flooded either in the riverine or in the urban areas, and then what are the along the river, the regions where we should think of the habitat modeling. So that is where we have said about the ecology. By doing this, not only you are able to identify the hot spots, but you are able to predict that what is the flood level it can come in terms of the depth, in terms of the magnitude, what is the lead time with you, and where are those locations where you are going to get. So this kind of the predictive and this kind of the the assessment which help you in taking the right measures, appropriate actions. That is where this GIS and the machine learning are going to help you, but certainly you have to make use of in the operation into day to day. So this is what I would like to say. Thank you for this.
Thank you, Professor Keshari. He, as I requested, he really touched upon the points of AI, ML, GIS and GPS, the whatever could be used, all this, and GeoAI in particular for the good. And he also talked about the policy intervention, use of technology in planning, operation as well as management. The one good point which he mentioned is, yes, for all building permissions, we talk of the setbacks, we talk of the height, we talk of the structural proof, structural testing, but we never talk of any drainage or water supply or even power. Power also has similar problems. So I think that's a good point which we should certainly have a takeaway. He has explained about a few projects where they have used the new technology by such as using satellite on the remote areas and remote sensing in the particularly border areas, and about his Ethiopia project and few of the Delhi projects. Thank you, Dr. Keshari. I think we are not left with any time for the question and answer. Each one has explained, and we have concluded that yes, technology is the solution in the current scarce water, good water supply to the human, more so in Indian context. That's the final word. Thank you. Thank you.